Wow, thank you so much, Paul. That was a really fascinating journey through the life of John Tyndall. And for those of you watching, you'll notice somebody's appeared next to me in the corner of your screen. So it's my absolute pleasure to welcome the previously named Roland Jackson, author of The Ascent of Tyndall, and trustee of the Royal Institution as well. So it's very handy that we can call on such a wealth of expertise just to help us out in the questions. So yeah, if you do have any questions about the life of Tyndall at all, do drop them into the comments or into the chat on the side, and I can put them to the two researchers that we've got here. So to kick us off, something you didn't mention, I wonder if Roland, you might maybe like to come on and talk about this a little bit. Paul Nugent said, unfortunately, Tyndall had a tragic death. Would you like to explain a little bit more about this?
Yes, indeed. And just to say thanks for that talk. That was really great. And I especially like looking at the diamagnetism stuff, which I've not thought about for a while. Very complicated stuff. Tyndall's death, yes, very, very sad. His wife, with whom he was besotted, was looking after him when he was really quite unwell in 1893. And he often took a sleeping draught of a small dose of chloral to help him go to sleep. And he took milk of magnesia as well in the morning to sort of settle him. One dark morning on the 4th of December, 1893, as he woke up, Louisa reached in the dark for the bottle of milk of magnesia, spooned out a very large dose and gave it to him. Unfortunately, it was chloral. And a large dose of chloral is fatal. So they realized immediately. And Tyndall looked at her and said, my darling, you have killed your poor John, or words to that effect. They tried to make him vomit it up, but failed. And about 10 hours later, he faded away, sadly. She then outlived him by some 47 years, which I'm afraid is part of the reason that he's not better known, because she tried to write a biography of him, failed, and it wasn't produced until after her death the book was produced in 1945, so about 50 years after Tyndall's death. And that's one reason, I think, why we don't know so much about him.
And Roland, your book's actually the first biography of Tyndall for quite a long time, is that right?
That's right. I'm just trying to think when. It's sort of the first major biography, I suppose, anyway. There was a series of essays written about him in the 1980s and a biographical study written more recently. But yes, this is the first major biography, apart from that one that came out in 1945.
Wow. And yeah, so for such a pivotal figure, it's just amazing that, there are just shelves worth of books about all of his different discoveries. And see Paul's nodding vigorously at the corner. The question that I had in my mind, and actually somebody else, I'll just remember the name of it. I'll give you a shout out to Martina, who also asked this. Great name. She asks, can diamagnetic levitation be used for like monorails and other areas where we use, other forms of levitation? Surely this is a great technology we should be using more.
It's an absolutely fabulous question. Why, with no power input? It's because the force is so weak compared to magnetism. You're levitating carbon. In fact, I wish I could let you touch one of these. It is so light. And so if you have extraordinarily strong magnets, which I did, these are neodymium ion boron magnets, where they will fly across the room if you let them get near to each other. They have a sufficient magnetic force to overcome the power of gravity and levitate this object made of carbon. But to levitate something like a train, it's not possible. The force isn't large enough. So with magnetic levitation, what you're doing is you're putting another magnetic material, and you're using superconducting magnets to generate a very high field with a feedback mechanism to allow you to stabilize the train over the track. Because if you get one magnet, North Pole, and try and hold it over a North Pole, I'm sure you've tried this, there's no stable point. So there is no stable point of levitation for an object which has both attractive and repulsive forces. But there is for an object which only has repulsive forces. So basically, it's not strong enough. But I think there could be applications coming, very sensitive applications, like vibration detection, for example. And there are some applications, people just starting to look at moving objects on the micron scale or the submicron scale, moving objects along surfaces using diamagnetism. Because most things are diamagnetic. I am, you are, a tomato is, a frog is. Most things are diamagnetic. So if there was a high enough field, you could levitate me or you about 45 Tesla.
I believe some researchers have actually levitated a frog. Is that right? That's the using diamagnetic principles. I think I saw a video of that a few years ago. So,
yes,
so you can get to the
yes,
sort
Andrew Geim levitated a frog.
So that's, well, how big's a frog? Like 200 grams, sort of. It's quite,
Yeah,
it's starting to get fairly good weights, I think, of things you can use. So there was another question asked by Norman, or sort of a statement really, but I just wanted to ask Roland about this. Norman says that Tyndall anticipated the hard problem of consciousness in 1868, referring to an impassable intellectual chasm between the physics of the brain and the states of consciousness, even if all the details were known, which is not something I knew, Roland. Would you like to add any more to that?
Yes, very much. It's something he thought about really quite early, actually. There's in his journal in the early 1850s, I think. There's a description of a long conversation he had with a friend about how consciousness arises and how the mind is or is not separate from the brain and so on. But he was in a sort of physical sense a materialist. He thought that the brain operated on material principles, so that you should be able to trace thoughts to patterns of molecular action in the brain. But he said that even though you might in principle be able to do that, you could never make the sort of sensible connection between one and the other. In other words, he said that something like the concept of love and the molecular interactions responsible for it would forever be incalculable and just simply not understandable. So yes, he had that view of a physical mechanism for the mind, but thought that we would never be able to, and that you could match a thought to molecular patterns in the brain, but that seeing those molecular patterns, you'd never be able to imagine what the subjective feeling of the person would be, which I guess is a statement of the hard problem of consciousness.
Yeah,
he wasn't alone. I mean, there were people like Emile Dubois-Reymond in Germany who were thinking similar things. And in fact, Tyndall may have got his later ideas from him.
Interesting. So there's another question here about diamagnetism, which I absolutely don't understand. So someone else will have to try and Paul, can you help us out here? So Philip Ward asks, is diamagnetism actually repulsive force? He said the Meissner effect in superconductors is not just repulsive, it's expulsion of a magnetic field. He says, see our video about the Mobius strip of neodymium magnets, which is a great video and you should all watch. But I'm not quite sure about the question. I'm not quite sure what Meissner effect is.
Meissner effect is where you use superconductors. So it's a slightly different effect. If you go down to extremely low temperatures, then the superconductor will have currents flowing, and it will expel the magnetic field from the material. This is not the same as diamagnetism. So diamagnetism is a repulsive force in that you have an atom with an electron moving around it. You then bring a magnetic field. The electron will experience a force. Moving electron will experience a force. The force will be such as to oppose the magnetic field, which is causing the action. So if all the electrons are paired up and there's no net magnetic moment in the material, either by spin or angular, either by orbital magnetization or spin magnetization, if there's no net magnetic moment, the effect of the magnet on the material will set up a magnetic field to oppose the force that's causing it. So I would see that as setting up, being repelled by the magnetic field. So I think I would consider that to be a magnetic force, because it is the action of a magnetic field on electrons moving around atoms.
And just another question from me, which about diamagnetism, which I sort of only just thought of really, but presumably things that are also ferromagnetic or things that are also paramagnetic will also show diamagnetic properties as well, if you could get a detector sensitive enough to measure them.
Yes, exactly. That they're overwhelmed by paramagnetism, or ferromagnetism is so much stronger than the diamagnetic effect that it will be overwhelmed by the force of attraction and repulsion. So diamagnetism should be present in all materials.
So we haven't had a huge amount of questions, because I think most people are just have been really enjoying the talk. But one question that I might put to you, just to try and draw things to a close. Stephen Roderick asks, are there any discoveries made by Tyndall that are still languishing, waiting for someone to pick up and explore further? Now, Roland, I know you've probably read more Tyndall correspondence than pretty much anyone there is. So is there anything that you found when you were going through his notes, his papers, that sort of leapt out at you as being kind of previously unseen or undiscovered?
Well, that's a great question. I think I've probably read every single paper that Tyndall's written. So and looked at pretty much all of his experimental notebooks. So I don't think there's anything significant that, if you like, people haven't noticed in one sense. But I don't think that's quite the whole thing, because there are always things that you can find out and explore more. So the work on diamagnetism, for example, hadn't been much studied until a few years ago, and I wrote a very large paper on it. And even then, I was conscious that I hadn't really got to the bottom of it. So I think there's probably more to be found there. If you look at Tyndall's other work, a lot's been done on his work on absorption of heat, on germ theory, on glaciers, on light. I think one area that hasn't been explored as much as others is his work on sound and the transmission of sound in the atmosphere. And I'd love to see somebody take a really hard look at that and tease that out a bit, because that's really quite interesting. It does also link up with some of his heat absorption work. So I think if I was going for something next, I would go and look at his work on sound.
Paul, did you want to jump in?
Yeah, there was two things I was going to mention. One was on the issue of sound, as Roland mentioned, is that do you hear more when there is, say, a storm coming? For example, one aspect of work that Tyndall did is using flames. He was able to show that sound is at least partially reflected by a change in air temperature or air density. There's a comment that I've heard people say on occasions: you can hear better sounds when a storm's coming, and so because it's reflecting off the different mass of and the density of the storm which is arriving. But it seems contradictory, because will a foghorn be more effective in the fog or in clear air? And again, it seems contradictory. From the lab, you think, well, it should be worse, because the sound should be scattered off these objects. So I think there's a tremendous amount that could be done with following up his work on sound. The other was something I took out of my presentation, and it was incredibly detailed work on diamagnetism and the issue of optical axis of materials or alignment of materials, whether they are crystalline or whether they're amorphous. These are extremely difficult experiments to do. And he published an enormous amount of work. He looked at one paper I saw, he had 33 different types of wood aligned between, in his magnetic apparatus, whether the fibers were aligned or not aligned, and this issue of the optical axis of a crystal, whether or not it was repelled by a field. I started to wonder when I looked at this, but I'm absolutely no expert in magnetism. Was he seeing early examples of magnetic and diamagnetic anisotropy? but the work is extremely complex, because when you turn on the magnet, it can induce currents in the sample, and you're suspending it between with a tiny piece of silk. And so William Bragg of Bragg diffraction and X-ray analysis wrote a paper on his work, I think in the 20s. And it was almost inconclusive. It's as if people haven't continued this work. They're extremely difficult measurements, but I think it's an area that could be revisited, the effect of different materials and their crystalline structure on diamagnetic repulsion.
So just before we draw things to a close, Roland, I see you've been reaching for a notebook. I don't know if you've been following the chat, where we've had a request from a few people just to close the show with a few lines of Tyndall poetry. I don't know if that's what you were doing when you were reaching for a bookshelf just then.
It's funny you should say that, because I had seen that as well and wondered if a request was coming. So can I take the opportunity to show this, which looks to me like it's the wrong way round. Is that showing okay on your screen or not? Yeah, okay. Yep. So literally published 2 weeks ago or so, The Poetry of John Tyndall by UCL Press. It's available free to download as a PDF, so open access if you want it, or some lovely handsome copies to buy. And it contains all 76 of the poems that we know, with an introductory essay by me and a couple of other colleagues. And I'll just read a few lines from probably his last and best known poem, which is called A Morning on Alp Lusgen. That's the Alp on which he built his chalet above Belle Alp. This poem was actually written as a homage to Thomas Carlyle, his great friend, who died in 1881. So it was first written in 1881. And this is just a little bit of it. It's a lovely poem, but it goes to sort of the heart of what the universe is about. Whence the craft which shook these gentian atoms into form, and dyed the flower with azure deeper far than that of heaven itself on days serene? What built these marigolds? What clothed these knolls with fiery whortle leaves? What gave the heath its purple bloom, the alpine rose its glow? Show us the power which fills each tuft of grass with sentient swarms, the art transcending thought, which paints against the canvas of the eye those crests sublime and pure, and then transmutes the picture into worship. O babbling Gnostic, cease to beat the air. We yearn and grope and guess, but cannot know. And there's Tyndall actually at the end of his life, thinking that science doesn't provide the answer to everything. There is a power or something beyond our understanding which fills the universe. So yes, he was a materialist, but also he had a sort of pantheistic view, in a sense, of the wider nature in the universe and our place within it.
Wow, what a wonderful note to end on. So just before we go, just a few things just to run past you. Just a reminder, anyone can join as a member, as a patron of the Royal Institution, and you can join the likes of me and Roland and John Tyndall and many other people who are or have been members of the Royal Institution. If you've enjoyed the stream, please do donate £10 to help keep us going. You can also buy copies of The Ascent of John Tyndall, published by Oxford University Press. Is that right, Roland? As well as the as well as the poetry book, so do check those out. Before we go, Paul, is there anything else you'd like to say, or where can people find you if they want to find out more?
Well, I'm Tyndall, so Paul.Hurley at Tyndall.ie. So if you want to contact me on any aspects or anything about the work we do here in the Tyndall Institute, please do. And I very much look forward to the time when we can also meet in person. So I just like to finish off by saying again, thank you for the opportunity to share, maybe from my perspective, some aspects of the life and works of John Tyndall, and how in our part we're trying to carry on his memory and his legacy here at the Tyndall National Institute in Cork.
Fantastic. And next time you're allowed over to London and we're in slightly more freer times, do drop myself and Roland an email, and we'd be delighted to give you a tour of our museum. And I'm sure Roland can take you into the archives and show you some Tyndall papers and all kinds of exciting stuff. So yeah.
Thank you, and likewise for both of you. And anyone and you can come to Cork.
Fantastic. Well, thanks everyone so much for joining us, and we'll see you next week. Take care. Goodbye.